Welcome to the Energy Essential Power Perspectives podcast, the show where we bring leaders, movers, and shakers in the utility industry directly to you. I'm your host, Jason Price of West Monroe, coming to you from New York City. And joining me once again from Orlando, Florida, is Energy Essentials community manager and podcast producer, Matt Chester. Matt, today's topic is on vegetation management. I have to believe, being in a warm weather climate year-round, like you are in Orlando, this must be a major issue. How would you rate Florida's utilities in managing vegetation management?
Yeah, Jason, you're right that the year-round warm weather and kind of lush trees and greenery, I think, lend to more need for vegetation management, not to mention, we're always right in the line of hurricanes and downed trees and power lines. So the utilities here, I think they're usually well prepared to stay on top of potential issues, but it's not a perfect system and outages aren't terribly uncommon.
Yeah. Well, specifically, we're going to dive into the world of vegetation management in the electric power industry, and our listeners may not realize how critical and complex vegetation management really is, as their only interaction may come if a tree in their yard starts to interfere with local distribution wires. So why is this important? It's the fact that issues can and do arise every day for utilities, whether this means overgrowth on vegetation onto the power lines and the electrical system, or from trees falling down. Anywhere on the path between generation and customer, this could get disrupted. These issues can cause significant fires and lead to enormous damage to property and lives. As an example, in 2019 in California, about 60% of the wildfires under the umbrella of the California Department of Forestry and Fire Protection were caused by vegetation coming into contact with power lines, meaning they were entirely preventable. Our audience will recognize the immense investment that vegetation management requires for utilities, from a multi-million-dollar line item for smaller utilities to a top 3 most costly expenditure for large utility operating costs. Further, vegetation management teams that aren't fully equipped to do their job efficiently and effectively are put into unnecessarily high risk profiles. So today's guest is here to share with us how vegetation management is evolving in the 21st century. The battle to push back and control vegetation growth has evolved from the days of cherry pickers and chainsaws to a sophisticated array of tools that includes satellite imagery and the use of artificial intelligence that takes considerations in factors like storm events, climate change, and other critical inputs that will help us all protect the grid, and ecology due to climate change and other complex analytics that all feed into the vegetation patterns. Our podcast guest today is Sven Przywarra, the co-founder and co-CEO of LiveEO. With his team at LiveEO, Sven is tapping into the capabilities of satellite imaging to be an eye in the sky from major infrastructure networks, including oil and gas pipelines, railroad networks, and power transmission and distribution networks. Using that imagery and intelligent processing tools, Sven and the LiveEO team are transforming the way that utility vegetation managers do their job. But before we bring Sven to share more, let's give a quick thanks to LiveEO for making this episode possible. LiveEO's market-leading satellite-based vegetation management solution is in use with utilities across the globe. Go to the LiveEO.com website, and that's live-eo.com, to find out how satellite analytics can transform your utility vegetation management program. So with that, let me introduce Sven Przywarra. Sven is one of the 2 founders of LiveEO. As a self-described startup enthusiast, Sven has spent his career bringing new technological tools to numerous industries with his ability to recognize where intelligence can transform business operations. With a background in engineering, politics, and business, Sven is perfectly suited to tackle challenges he's passionate about, and that includes climate change, business efficiency, and optimizing decision-making. Let's not wait a moment further. So Sven Przywarra, welcome to the Energy Essential Power Perspectives podcast.
Hi there. Thanks for having me.
Sven, let's start with the basics of the problem you're solving. Why is utility vegetation management so important, and how do traditional methods fall short?
So you already mentioned a lot of reasons why vegetation management is so important, because it really helps to keep the grid up and really have a high degree of reliability when it comes to our energy supply. But why did traditional methods fall short? Traditional methods are, for example, helicopters, drones, equipped with LiDAR sensors, or equipped with someone who visually inspects the lines. These visual inspections are prone to error. For example, don't really take into account sag and sway, so different technical terms of the overhead lines. The most important thing to all the previously mentioned methods is that they are there, they are in use, but they are difficult to scale and to some degree inefficient. And really the most important point is that because all these technologies have a certain speed, it's really difficult to get an overview over the entire network, which makes it difficult to prioritize work and to coordinate field workers really efficiently.
Now, what are you and your team at LiveEO working on now that can solve this problem? A lot of people throw out the terms intelligent about their solutions. What are you guys doing differently?
Yes, you're absolutely right. Somehow everything is supposed to be intelligent today, from our phone to our fridge. But let me explain you in a nutshell what we do. So what we do is we acquire satellite imagery from a various range of satellite operators like planets, Airbus, and others. We then take this data, harmonize it, and analyze the imagery with machine learning algorithms to detect trees which are too close to the overhead lines on a transmission and distribution level and assess their condition. What we do then is we apply risk models to this information to detect not only where trees are, but where these trees pose a high risk to the spans of the overhead lines. And then what we do is we translate this risk assessment into work orders for inspection teams and trimming teams so that cutbacks can be prioritized. We all make this available to the vegetation managers of the utility and to their subcontractors, to whoever needs to be in the loop via our web and mobile app. And additionally, we have integrations into already existing systems. So really, we go all the way from the raw imagery to speaking the language of the utility and providing them with the information they require.
Sven, how long does the process take for a typical case?
Yeah, so this is really one of the great advantages of satellite data. I've mentioned the current existing methods, which have limitations of, for example, the speed of a helicopter. Satellite data can provide you insights of 1,000 miles, 10,000 miles within weeks end to end. And we're speaking about the entire process I've just described. And once fully in place, updates can be even created quicker than that.
I imagine another key motivation for the state-of-the-art vegetation management comes from the increasingly prevalent wildfires and extreme storms that are causing outages across the utility industry. How do satellites come into play in these instances?
Yes, absolutely. So here, it's again the problem mentioned earlier. Without a grid-wide overview, which is up to date, it's really difficult to catch all potential risk trees which are too close to the overhead lines, which could fall into the overhead lines during a major storm event, or which could also get in contact with them and then cause a wildfire. What we do is we provide this overview and help there, but there are also other things which we can do. Furthermore, we can, for example, provide information on tree health and tree species, which are really important factors to decide which tree is a danger tree and which tree isn't. So it really helps you to narrow down from the millions of trees which are next to thousands of miles of overhead lines to really just a few which maybe are the ones with the highest risk potential. So this is all pre-active. There are also things where satellite data can come in to help reactive work once an event has happened. For example, we can help with post-disaster recovery. Well, we can do two things. First, we can evaluate where, for example, wildfire has struck and where the overhead lines have been affected by that to, for example, help the utility apply for recovery funding much quicker than they currently can. Or secondly, is that we have implemented and developed a solution which uses radar data, so a different type of satellite data, to rapidly acquire imagery right after a storm has hit a utility service area. And our analysis helps with identifying the areas within the service area which have seen the biggest impact by the storm. So where maybe the most overhead lines are down, where the most poles have been knocked over. And this information, which we can derive from satellite imagery just hours after the storm, can help utilities to prioritize their recovery work right after a storm. So there are really a lot of areas where satellite data can help to really get utilities to deal better with the current situation, with the current weather situation, And this is really, we think, amazing.
Yeah, I would say so. What's changed that's made satellite imagery now an option?
Yeah, very good question. So the reason why Daniel, my co-founder, and I started in this industry, or in the satellite data analytics industry in the first place, is because we independently came to the conclusion that right now we're going through a revolution Earth observation. What does this mean? So satellites have been around forever, but there were just very few satellites in orbit. They were not really capable of a lot of things. They were used in areas such as, obviously, in the intelligence space, helping with governmental tasks, and to some degree in agriculture. But then something happened. Space became privatized. Obviously, SpaceX is a big name, but there are other companies as well, like Planet out there, Rapid Eye. These companies, for example, have sent hundreds of satellites into space, which monitor every place here on Earth. And there are multiple of these companies out there. So this really means that you now have much more satellites in orbit than just a few years back. The cost of this data is much lower than it has been a few years back, and their capabilities are much higher. So we can now analyze vegetation here on ground with a resolution of around 30 centimeters, so 1 foot. That really enables a whole range of new use cases, which I just described. So that's really the reason why we're able to help utilities with satellite data in 2021 and forward.
Yeah, and with the the proliferation of satellite imagery, it's available. It's almost ubiquitous. You can pull this down from many different sources. So why would a utility need LiveEO rather than just pull this themselves from what's available in the public?
Yeah, that's an interesting question, which we sometimes get. Sure, it is possible for anyone to download satellite imagery once you've made the contract. So sometimes this can already be the first barrier. But the value of our solution is really not in the raw imagery, which you could look at yourself, but the value is generated through our end-to-end analysis. What we do is we don't only take imagery from one operator, but we combine satellite data from various sources to enhance the quality of the analysis. So what we do in the first step, and what most probably would be very difficult for a utility, is to assess which satellite vendor has the right data, where can we combine different data sources, and where can we also get the best price for that data. It would most probably be very difficult for a utility to assess which data from which satellite vendor would be the right one. What we can do here at LiveEO is we can assess this, we can combine different data sources with one another. What we can also do is we can negotiate on price, because our goal is really to bring the cheapest, the best product to our utility clients. So this is the first step. But then we analyze this data, because without an automated analysis of the imagery, you have not gained really a lot, because you still would have just imagery over thousands and thousands of miles, which you would then manually go through. So what we have developed are algorithms which translate this raw imagery into actionable insights with real high accuracy. We have analyzed hundreds of thousands of miles to reach the reliability of detection we've achieved today, and which is necessary for utilities. So since we've already worked with utilities now in 5 continents, with multiple utilities in the US and Canada, every utility benefits from the developments which we've made for other utilities, right? So it's really a product which we've built here. And from the imagery, we not only detect where trees are, but also their height, their vitality, and what tree species you are dealing with and where these trees are. And this, again, is really, really difficult. But it also not only ends here. We have created this risk model, which works for most utilities, and where we have fallen risk and really taking into account the catenary curve. And again, that's deep development, and millions of US dollars have flown into this. So it would be very costly for the utility just to buy the imagery, then just look at the data manually, or buy the imagery and then develop all of this for themselves. Yeah, so that's the reason why we've seen a lot of utilities working with us instead of doing it on their own.
Interesting. You mentioned the work you're doing in North America. So you can't have a conversation about the utilities without including the regulators. So what is the regulatory environment? Do you have any anecdotes or use cases to share on their perspective regarding this technology?
So satellite data can really help to deal with the regulatory requirements set by the regulator. Obviously, there's NERC regulation out there, which requires some type of analysis, for example, with LiDAR, or where a lot of utilities already have decided to use LiDAR. And it's fine, and we can speak about this in a second if you want. But satellite data can help to deal with the requirements to really monitor and maintain vegetation alongside the entire network to create a reliable net and safe network for all customers. And this is really what we're doing here. So since you know that on a state-by-state level, there are very different regulations, there are no regulation whatsoever in some states, right? Our tool is really flexible. For example, our risk models can be adapted to the regional requirements or to the federal requirements. And with this, we can help to identify the risk trees, which maybe under the regional state requirements would be a risk, or which would be under federal requirements be a risk. Our data comes in there.
Yeah, you're leading me to my next question. You mentioned LiDAR. So LiDAR, drones, helicopters. So there is technology that is being deployed today to manage this problem. Do you find that this technology is complementary to LiveEO, or do you feel that the satellite tools and the AI is something that can replace what's currently out there in the marketplace?
Yeah, I would say both, and it really depends on the use case. So drones and LiDAR are super cool, no questions asked. And really, for some applications, they are the only tool out there which can help you with identifying, for example, where, I don't know, an isolator on top of your power pole is broken or whatever. But for some applications, it's much more than needed. So it's a little bit of an overkill and therefore relatively inefficient. So for some use cases. So it's really a combination of these two technology, which can help vegetation managers across the United States and Canada to get the biggest bang for their buck. So, for example, many cases, especially on distribution networks, our analysis can replace the previously mentioned methods, drones, LiDAR, which are needed for monitoring these overhead lines. On the transmission side, where regulation obviously is much more strict, satellites might not be able to replace other solutions entirely, but are still an important addition to the toolbox of a vegetation manager, because it allows them to do much more of what they are already doing. For example, LiDAR, much more efficiently at the critical spots. So if you fly a LiDAR maybe every year or every second year, satellite data can help you in the meantime to identify where there are sick trees, but can help you to catch cycle busters. It can help you to prioritize where you want to fly LiDAR first. So really, it's a combination of these two technologies. And additionally, satellites are able to detect other things as well, encroachments within the, so building encroachments between two LiDAR flights or between two drone flights. So how I always compare it is that drones and LiDAR give you a snapshot, a high resolution snapshot of something. And satellite data, for example, gives you a continuous monitoring solutions. And so you can combine these two technologies really well, both on the distribution and transmission side.
Yeah, I have to admit, satellite analytics is a really cool topic. I think the work you're doing is pretty interesting. But can satellite analytics do it all? I mean, you can unlock optimized vegetation management strategies, I suppose, but where are the limitations on this kind of technology?
Yeah, sure. Nothing is perfect, right? But as just mentioned, satellite imagery does not reach the spatial resolution, for example, of LiDAR. So there are limitations in that sense and in that area. For example, as already said, right, we can't make good assessments of any kind of isolator condition of any kind of oxidation of anything or something like this, which really goes much lower than the spatial resolution of a satellite pixel. But on the other hand, we have now reached a point regarding the quality of satellite data and of our algorithms involved, where there's a very solid business case for satellite-based vegetation management. And with new satellite constellation, and there are some of them already up in orbit right now, the quality will improve. And vegetation management is our main use case, right? But in the beginning, you already mentioned that we are also working with pipeline operators, railway operators. So for example, what we do is we monitor ground deformations based on satellite imagery, or we monitor encroachment of buildings into the right-of-way, or people building something in the right-of-way. All that can be also monitored by satellite data. So there are a range of use cases where satellite data is sufficient and can really help to make the operator's life easier.
Utilities are a pretty conservative bunch, so you must get raised eyebrows when you pitch this kind of technology to them. If you don't mind, share with us your sales pitch. Like, how do you approach them? What's the conversation like? What's the response on this technology when you present it to them? What do you see as the future in terms of adoption of this kind of a tool in the utility industry?
Yeah, you're absolutely right. But you would be surprised. So the reports we get from our customers where we've already rolled out our solution with field workers and with the management is that the people in the field love our app and working with the systems. On the one hand side, satellites are obviously very cool and I love them as a gadget. And obviously the technology is super fascinating. Our tools and the analytics just make their lives much easier because they already know what to expect when they drive out into the field to any given span. When it comes to vegetation managers in the office, you're right, obviously. Most of the people are very open to innovation and new technologies, but obviously they also have great responsibilities. So we, for example, talked just now about the disaster and severe weather events that happen. So it naturally evokes skepticism to new solution, which is something I fully understand. That's why we typically run a pilot with our customers and do an analysis for a part of the network so that we can show our capabilities and they can get really comfortable with what the technology can offer. This way, the customer can get a feel where our solution can bring value and where it fits into their processes and routines. This is really crucial to get any adoption within a utility. It also gives us a chance to fully understand the needs of our customers and where the solution is the right fit for them. But we also openly express when we see, well, okay, good, satellite data can't offer that. So we think open communication is super important, and it also includes communicating very openly where your technology can't help, right? So this is super important, and I think this is also one of the keys to success for us. So in the end, the initial risk for the utility, for the vegetation manager is really, really low. And pretty all we need to get an analysis started for a utility, for a vegetation manager, is just the GIS data of where their lines are. And then we can already demonstrate that and take the conversation from there.
Yeah. Well, I'm based in New York City, so all our power lines are underground. But I imagine, Matt, for you in Orlando, I'm sure the next time you see a line worker cutting trees or removing vegetation, you're going to probably wonder if that was spurred by a LiveEO report.
Maybe I'll give them a tip that they should be looking at it.
Well, Sven, this was an awesome conversation, and we really want to thank you for today's discussion and the insight that you've shared with us.
Yeah, thank you very much. It was a pleasure, and really love to be here on the podcast. Thank you.
Beautiful. You can always reach Sven through the Energy Central platform, where he welcomes your questions and comments. And on behalf of the entire Energy Central team, thanks to everyone for listening today. Once again, I'm your host, Jason Price. The most relevant conversations of the utility industry today are happening in the Energy Central community. So we look forward to you joining us and sharing your insight at energycentral.com. And we'll see you next time on the Energy Central Power Perspectives podcast.